Hello, my dear students. Raman Rana here, mathematics teacher, Cambridge International School, Jasua. Today, we will start the new chapter, Triangle. So, I hope you are doing your best at home and you are enjoying your e-classes. Triangles. Triangles we are studying from lower classes. What is the triangle? Different types of triangle, different properties of triangles. In grade 9 we have studied congruent triangles, and in grade 10 specifically we will study the similar triangle, the concept of similarity. So triangles definition first. Triangle a closed figure formed by three intersecting line is called triangle. Tri means three sides. A triangle, let ABC is any triangle, A, B, C, triangle ABC is having three vertices, three vertex point A, B and C. It is having three sides AB, BC and AC, and three angles, angle A, angle B and angle C. So we know the various properties, like the angle sum property of a triangle says that the sum of its interior angles, all three interior angles, is always 180 degree. Exterior angle sum. Now, types of triangle. Triangles on the basis of angles, on the basis of sides, on the basis of angles, like we have acute angle triangle, obtuse angle triangle, equilateral triangle, right angle triangle, we have secant triangle, isosceles triangles. So we have so many kinds of types of triangles. Now, two triangles are said to be congruent when their corresponding sides, the word corresponding is very important, the corresponding sides are equal, means congruent. The word congruent means when the shape is equal in all respect. Two triangles are said to be congruent when triangle ABC is congruent to triangle PQR, when angle A is equal to angle P, angle B is equal to Q and angle C is equal to R. And corresponding sides, side AB is always equal to PQ, angle BC, the second side BC is equal to QR, and the third side AC is equal to PR. This is a sign of congruency. Two triangles are said to be congruent when their corresponding sides are equal and their corresponding angles, angle A is always equal to angle P, angle B is equal to Q and angle C is equal to angle R. Then we say that these two triangles are congruent. So we have 6 things, 3 sides, corresponding sides, and 3 corresponding angles. These 6 things are there, then we are saying triangles are congruent. But in grade 9 we have studied some rules. We are going for some short rules for congruency. These rules are like, we have studied side angle side rule of congruency. We have studied angle side angle rule. We have studied side 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 rule of congruency. One more rule, that is angle angle side. We have studied right angle hypotenuse and side. So we have studied these rules in detail in grade 9. Now in grade 10 we are talking about similarity. So what is the difference between congruent figures and the similar figures? So as we know that congruent figures, corresponding sides and the angles are same. Congruent means same shape, same size. Same shape, same size. Similar figures need not to be of same size. In similar figure, shape will be same, but size may vary. Size may be different. So, dear students, in grade 9, we have studied some other properties of a triangle. Let's recapitulate all those points. Like first, we have studied the midpoint theorem. Midpoint theorem. Midpoint theorem says that if we take the midpoints of the 3 sides of a triangle, let D is the midpoint of AB, E is the midpoint of BC, and F is the midpoint of AC. So whenever we join the midpoint of any 2 sides, it may be AB and BC, means join D with E, or E with F, or join D with F. Let's suppose we are joining this side D with F. So midpoint theorem states that this line segment DF is always parallel to BC, and this DF is always half of BC. So 2 things in midpoint theorem we have studied, that DF is always parallel to BC and DF is always equal to half of BC. This is the midpoint theorem. Here in this triangle, if we join D with E, if we join this triangle D with E, then this DE is parallel to AC and half of AC. Similarly, the third side, when we join E with F, then this EF is always parallel to AB and half of AB. So we have studied in detail. Even we have studied that these 4 triangles are of equal area. Even we have studied that these 2 triangles are congruent. Even we have studied that DBEF is a parallelogram. So next important theorem we have studied that median of a triangle divides the triangle into triangles of equal area. We have also studied the inequalities in a triangles. Inequalities in a triangle. First, median. We have studied about the medians. Median, when any triangle, if we are choosing any vertex A and the opposite side BC, if we take the midpoint of BC, when we join these two points A with the midpoint M, these two triangles are always of same area or equal area. They are not congruent, but their area is always equal. This is the property of medians. We have proved in grade 9 also, because these two triangles, their base is of same length and height, corresponding height to these two triangle is same. Now, other properties which we have studied in grade 9 is triangle inequalities, properties of inequalities in a triangle. If any triangle A, in which any one side of a triangle is A, length of the side is A, B and C, then always for any triangle, the sum of any two sides is always greater than the third side. Means C plus B is always greater than A, or A plus C is always greater than B. Even very important property we have discussed, that if in a triangle, if we have the smallest angle out of these three angles, the side opposite to the smallest angle will be of the shortest length. Similarly, if larger angle of a triangle, the side opposite to the larger angle is always the longest side of a triangle. So there are so many other properties which we have studied in grade 9. Our topic of grade 10 is similarity. So what is the use of congruency or congruent figures in our day-to-day life, of similarity in day-to-day life? We will discuss here. Let me take some examples. Bangle. If bangle of same size, they are congruent. ATM cards issued from the same bank, they are of same shape, same size, they are congruent. One real life applications we are using are pens. Refill. If we are using some different refill that is not fit in our pens and ball pens, so there is a direct application of congruent. Refill should be congruent. Now, congruent figures and similar figures. Similarity, when shape is same but size is different, size may vary. All congruent figures, they are similar, but similar figures need not to be congruent. So this is very important thing, that all congruent figures are similar, but all similar figures are not congruent. So in similarity, we have same shape and size may vary. Same shape but different size, If ABC is a triangle, and if we have a triangle PQR in such a way that let this angle is equal to this angle, A is equal to angle P, angle Q and angle B are of same measure, and angle R, third angle, is also equal to this third angle. So we says that the triangle ABC is similar to triangle ABC is similar to triangle. This is a sign of similarity. This is a sign of similarity. So two triangles are similar when their corresponding angles are equal and their corresponding sides. Corresponding angle means angle A is equal to angle P, angle B is equal to angle Q, and their third angle C is equal to angle R. So again we have the 6 things: 3 corresponding sides and 3 corresponding angles. In similarity, we have the ratio of these corresponding sides. Angles are equal. Angle A is equal to P, B is equal to Q, and angle C is equal to angle R. But about the sides, in congruent figures, we have corresponding sides equal. But here, the ratio of the corresponding sides is same. Ratio means here AB upon PQ is always equal to BC upon PQ, BC upon QR, and the third side AC upon PR. These are the 3 corresponding sides, and they are always in same ratio or proportion. Same ratio, or we are saying proportion. So we will discuss in detail in grade 10 similarity of triangles. We will prove here the Pythagoras theorem. Even in day-to-day life, we are using the concept of similarity. How we have measured the height of Mount Everest. How we have measured the distance of very distant objects such as moon. We are finding these long distances with the properties of similarity. We cannot measure these long distances. We are using the properties of similarity. So dear students, let's start the topic similarity. So two similar figures, very renowned mathematician, his name was Thales. He gave the property of two equiangular, I am using the word equiangular triangles. Means the two triangles in which the corresponding angles are same. So with the help of construction, I will explain. Mathematician names Thales. Thales, he was a very famous Greek mathematician, and he gave a very important property of two equiangular triangles. So what does he say? Let me take the example of the triangles. If this point is A here, and again I am dividing, as we have gone through construction also, I am dividing 5 equal parts, that this is B here and this point is C. If I am joining B with C, I have a triangle ABC, and this side AB is further divided into 5 equal parts. Let these points are P, E, Q, R, any name you can take. And if by construction I am drawing one line parallel to the side BC, let this point is D here. By construction I am drawing a line DE parallel to the sides BC. Now I have two triangles ABC and triangle AED. So what we have? We have AE upon EB. AE is 2 units and EB is 3 units, 2:3. So by construction we have AD upon DC is also 2/3. So Thales gave a very important property. This property is called basic proportionality theorem. Basic proportionality theorem, popularly known as Thales Theorem, on the name of the great mathematician Thales. What this basic proportionality theorem says: if in any triangle, let ABC is a triangle, if any line is drawn parallel to any one side from anywhere, if any line is drawn parallel to any one side, let this is line L. Line L is drawn parallel to any one side. We can draw a line, if AC is a line, we can draw a line parallel to AC. Or if a side is AB, we can draw a line parallel to AB from anywhere. Here, if line L is drawn parallel to side BC, then this line divides the other two sides. Other two sides means AB and AC in the same ratio or proportion. Let this point is point D here and this point is point D. So what is the definition of basic proportionality theorems? Basic proportionality theorems says that if any line is drawn parallel to any one side of a triangle, then this line L, divides the other two sides in the same ratio, or they are always in the same proportion. So here always AD upon DB is always equal to AE upon EC. My dear students, this is the main basis, Thales theorem or basic proportionality theorem, popularly known as BPT. Very important theorem. Most of the time it is asked for 4 marks in the exam. So you have to learn the definition also, and for the construction you have to draw a triangle here, triangle A. Let this is a triangle ABC here. In this triangle ABC, let here anywhere D is the point and C is the point, in such a way by construction we are taking that these two points D and C, by construction, that what is given here that DC is parallel to BC, and to prove that AD upon DB is always equal to AC, that is AE upon EC. So we will prove this theorem, that is basic proportionality theorem. So BPT or Thales theorem. So question is asked, define and prove Thales theorem or define and prove BPT. Sometime examiner asks the question that prove that if any line drawn parallel to any one side of a triangle, if any line drawn parallel to any one side of a triangle always bisects the other two sides at two distinct points in a same ratio. So here first of all we will draw one triangle ABC, A, B and C. Here it is given here that any line, this line DE is parallel, DE is parallel to the side BC. To prove we want to prove that AD upon DB is always equal to AE upon EC. So we need some construction here. If from point E we can draw one altitude or perpendicular at, you can join this one here. Here this is the 90 degree here, and one more altitude from D on, let this is also a 90 degree here. Let one point is M and this point here is N. Now we have a triangle ADE. The area of triangle is base half into base into height. If I am taking AD as a base, its height is EL. And if same triangle ADE, if I am taking a base as AE, so altitude here is DM. Now we will start here that the area of a triangle, first step, area of triangle ADE is equal to half base AD and corresponding altitude here is EM, right? Similarly, we will join B with E. Why I am joining the points B with E? Because here I want to take the triangle BDE. From this triangle I will take the side DB. So here divided by triangle, area of a triangle BDE, this is equal to half into, now this is very important here, when in this triangle BDE, if DB is a base, the altitude will be EM outside the triangle. Roughly, if I am explaining, if this is a triangle here, this is the base of a triangle, like PQ is a base and R is a point here. So in this triangle, its altitude from the third vertex, let R is the vertex. So this is the perpendicular, or you can say altitude. The height, base is PQ, height is, let this is RS. So same here, BD is the base, EM is the altitude. So base is DB or BD and altitude is same, that is EM. So we will cancel half with half, EN with EN. So we have left with AD upon DB. So this is our equation number 1. So I hope it is very clear. Equation number 1, we took triangle ADE, its area half into base into height, and triangle BDE, its area is half into base into height. So this is equation number 1. Now we will join D with C. When we join D with C, again we will take same this triangle ADE upon, now we want to, in place of BDE, we want to take triangle CED, Now here this triangle area is half. Now I want to change, in place of AD I want to take the side AE. If I am taking the base of the triangle ADE as AE, so its corresponding altitude will be DM. Its corresponding altitude will be DM. I have explained here. So now triangle DEC or CED triangle, its area is half into base is EC and its corresponding altitude will be DM only. So here DM cancel in half. So this is equal to AE upon EC. We will take, this is equation number 2. So here from equation number 1 and equation number 2, we have both the sides, means right hand side of the equations, they are equal. So we need to prove left hand side, whereas in left hand side both numerator here, numerator is, that is the same triangle ADE, so its area is same. So we have to, with the third equation, we will prove with certain properties that these two triangles, triangle BDE and triangle CED, their area is equal. So why their area is equal? Grade 9 we have studied the concept, the triangles on same base and between same parallel always have, they are always of equal area or they have same area. So we'll write here that triangle, to correlate these two, triangle area of a triangle BDE is always equal to area of a triangle CED. So here you have to give the logic. Triangles, because triangles on same base and between same parallels parallels are always equal in area. So here DE is the same base for these two triangles, and these lies between these two parallels. So here we will write down, this is equation number 3 here. So from equation 1, 2 and 3, we have from equation 1, 2 and 3, that missing link we have now completed. The area of these two triangles CED and BDE, they are of equal area. So we have AD upon DB is always equal to your AE upon EC. So this is very important theorem, basic proportionality theorem, popularly known as Thales Theorem. So this is the main basis of this chapter. So dear students, let's recapitulate. We have discussed today about the congruent triangles and similar triangles, or congruent figures and the similar figures. Congruent figures have same shape and size, whereas similar figures, they have same shape but size is different. I want to give examples like circles. Different circles of different size, they are always similar. Same for square. Square of any sides, they are always similar. In the same way, triangles or equilateral triangles of any shape is same, of any size, they are always similar. So dear students, go ahead with the examples and exercise 6.1, that is very basic exercise, and work hard. This is a very important chapter. Stay healthy, stay safe and stay home. Thank you very much.